Have you ever thought you can't be successful because you don't have enough money, don't live in the right city, don't have the right connections, or don't know anyone willing to help you? Difficulties will always arise, but the true measure of an individual's character is how he or she comes back from the adversity and struggles. Do not accept defeat, no matter what has happened. We have one life, meaning one chance to chase the dreams we are given. So, we have to assess whether or not the problem in front of us is big enough to blow that one chance away. It's okay to be down. We all fall. Just make sure you get up even stronger. Albert Einstein famously stated, "Insanity is doing the same thing over and over again and expecting different results." Sometimes when we get into compromising situations, our first reaction is to blame everyone but ourselves. Change is scary. It's hard work and requires effort. We are creatures of habit, which is why making new ones is such a task. But if we want to succeed in areas of our lives at which we've previously failed, we must take a step back and observe and make adjustments. Anything else would be insane. There are no excuses. Life doesn't pity your circumstances or bend to your complaints. Be consistent on your words to yourself and for yourself. And take pride in the wins, no matter how small they may be.
Welcome to our lab again. It is great to see you. For today's experiment, we are going to study and compare the reactivity series of metals. Let's begin, shall we? How can we formulate the reactivity series of metals through the reaction between a metal and oxygen? The apparatus needed for this experiment are combustion tube, glass wool, Bunsen burner, retort stand, and asbestos paper. While the materials needed are potassium manganate, magnesium, zinc, iron, copper, and lead powder. Firstly, fill the tube with 2 spatulas of potassium manganate. Place the glass wool and then add 1 spatula of magnesium powder. Next, begin heating the magnesium powder strongly until it becomes very hot. Then, heat the potassium manganate to produce oxygen. Observe, magnesium burns rapidly with a bright white flame. After the magnesium has cooled down, it turns into magnesium oxide, which turns into a white ash. Now, repeat the experiment by replacing the magnesium powder with zinc powder. Begin heating the zinc powder strongly until it becomes very hot. Then, heat the potassium manganate to produce oxygen. Observe, zinc burns rapidly and glowing brightly. After the zinc has cooled down, it turns into zinc oxide, which changes its color from yellow when it is hot and white when it is cold. Again, repeat the experiment by replacing the zinc powder with iron powder. Begin heating the iron powder strongly until it becomes very hot. Then, heat the potassium manganate to produce oxygen. Observe, iron burns rapidly but glows less brightly than zinc. Iron oxide retains its reddish brown color even after it has cooled down. Again, repeat the experiment by replacing the iron powder with copper powder. Begin heating the copper powder strongly until it becomes very hot. Then, heat the potassium manganate to produce oxygen. Observe, copper has a slow reaction and only glows a little. Copper becomes a black solid after it has cooled down. Finally, repeat the experiment again by replacing the copper powder with lead powder. Begin heating the lead powder strongly until it becomes very hot. Then, heat the potassium magnet to produce oxygen. Observe. Lead reacts by burning slowly and glows dully. After the lead oxide has cooled down, it changes its color from brown when it is hot and yellow when it is cold. In conclusion, the more reactive metals react more vigorously and more rapidly with oxygen to form oxides than the less reactive metals. Therefore, the reactivity series in descending order of reactivity with oxygen are magnesium, zinc, iron, lead, and copper. For our next experiment, we are going to find out the position of carbon in the reactivity series of metals. The apparatus needed for this experiment are crucible, tripod stand, wire gauze, and Bunsen burner. While the materials needed are asbestos paper, carbon powder, copper oxide, zinc oxide, and aluminum. Firstly, place the asbestos paper in the crucible. Secondly, fill 2 spatulas of carbon powder and 1 spatula of copper oxide. Then, mix them evenly. Next, heat the mixture strongly for 1 to 2 minutes. Then, remove the Bunsen burner and examine the mixture. The mixture burns brightly and produces a brown solid because carbon is more reactive than copper. Next, repeat the experiment by replacing the copper oxide with zinc oxide. Fill the crucible with 2 spatulas of carbon powder and 1 spatula of zinc oxide, and then mix them evenly. Heat the mixture strongly for 1 to 2 minutes. Then remove the Bunsen burner and examine the mixture. The mixture burns slowly and produces a metallic grey solid because carbon is more reactive than zinc. Finally, repeat the experiment by replacing the zinc oxide with aluminum oxide. Fill the crucible with 2 spatulas of carbon powder and 1 spatula of aluminum oxide, and then mix them evenly. Heat the mixture strongly for 1 to 2 minutes. Then remove the Bunsen burner and examine the mixture. The mixture shows no reactions because aluminium is more reactive than carbon. Therefore, the position of carbon is between aluminium and zinc in the reactivity series. For our last experiment, we are going to find out the position of hydrogen in the reactivity series of metals. The apparatus needed for this experiment are U-tube, flat bottom flask, thistle funnel, combustion tube, and Bunsen burner. While the materials needed are zinc, hydrochloric acid, and hydrous calcium chloride, copper oxide, zinc oxide, and iron oxide. Firstly, place a spatula of copper oxide into the combustion tube, and then seal the tube properly. Next, fill the flat bottom flask with hydrochloric acid so that hydrogen can be produced and to be dried over anhydrous calcium chloride. The dry gas is passed through the combustion tube until all the air is displaced. Light up the end of the glass tube to ensure that the hydrogen escape from the combustion tube is oxidized to water. Now, heat the copper oxide strongly while allowing the hydrogen gas to pass through. Observe. Copper oxide burns with a bright flame. The black solid turns to brown because hydrogen is more reactive than copper. Next, repeat the experiment by replacing the copper oxide with zinc oxide. Heat up the zinc oxide strongly while allowing hydrogen gas to pass through. Observe. Zinc oxide does not glow or burn because it is more reactive than hydrogen. Zinc turns yellow when it is hot, but turns back to white when it is cold. Finally, repeat the experiment by replacing the zinc oxide with iron oxide. Heat up the iron oxide strongly while allowing hydrogen gas to pass through. Observe. Iron oxide glows red hot and it changes from a brown powder to a grey solid. This is because hydrogen is more reactive than iron. In conclusion, hydrogen is more reactive than iron and copper, but less reactive than zinc. Therefore, the position of hydrogen is between zinc and iron in the reactivity series of metals. That is the end of our experiments. Be careful when working with hydrogen because it may cause an explosion. Thank you and see you next time.